In our previous lesson, we have looked at how we can decompose rational functions into partial fractions. We've considered the linear factor type. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to look at another example on how we can decompose rational functions into partial fractions, where we consider the linear type. Now, let's consider the example. So in the example, it says that resolve 12x minus 5 all over 3x minus 1, then 2x minus 1, right, in partial fractions. So we want to look at how we can resolve this in partial fractions. Now, let's consider how we can resolve it, right? So the question given to us is 12x minus 5, right? So realize that the question is 12x minus 5 all over the denominator. We have two factors, 3x minus 1 and 2x minus 1. So we know that the first thing we do when we are decomposing rational functions is that we must consider the denominator, right? Ensure that you know the type of denominator that you have. So in this case, we have denominators that have linear factors, because when we equate them to 0, we will get answers that are linear, right? And the factors are not the same, but then they are linear and they are distinct, right? And then we must also ensure that the denominator or the numerator doesn't have a higher power than the denominator, which we have been able to see. Because when we expand this, the denominator, we get something in x squared, and the one at the numerator is x. So we can write this, right, as 12x minus 5 all over 3x minus 1 and 2x minus 1 to be equal to a all over 3x minus 1 plus b all over 2x minus 1. Right, now that we have done this, for the left hand side, we write the same way. So the left hand side will be written the same way. So you have 12x minus 5 all over 3x minus 1, right, 2x minus 1. That's the rational function we want to decompose. So it means that here we'll find LCM. And the LCM of 3x minus 1 and 2x minus 1 will be 3x minus 1 and 2x minus 1. So we see that 3x minus 1 will go into 3x minus 1. So we left with 2x minus 1. So we have a multiplying 2x minus 1. And then plus b, we have 2x minus 1 goes into 2x minus 1. So we left with 3x minus 1. So b multiplying 3x minus 1. Now we say that since the denominators are the same, right? Since the denominators are the same, then what we can likely do is to equate the numerator. So we have 12x minus 5 is equal to a multiplying 2x minus 1 plus b multiplying 3x minus 1. Right, so we are going to use the approach where we pick each of the factors and we use a linear factor of each of them to substitute into the equation. So we can say that considering, right, 2x minus 1, we can equate it to 0 and have 2x to be equal to 1. Divide both sides by the coefficient of the x, which is 2. Right, and that implies that our x will be equal to what? Half. So wherever we see x, we substitute half there. So 12 multiplying 1 over 2 minus 5 is equal to a, right? 2 multiplying 1 over 2 minus 1 plus b, 3 multiplying 1 over 2, right, minus 1. So that implies that when we consider it very carefully, we would have the 2 dividing the 12, we have 6 minus 5 here. And then we see that the a goes away because this goes into this 1. 1 minus 1 goes to 0. So it means the whole of the a goes to 0. Then we'll have the b, right? So we have b multiplying 3 over 2 minus 1, right? So we are going to have 6 minus 5 gives us 1. So 1 is equal to, right? So 3 over 2 minus 1 gives us 1 over 2, right? So we have 3 minus 2 all over 2. So 1 over 2 multiplying b, right? So we can cross multiply and have our b to be equal to 2, right? So we cross multiply, right? 2 multiply the 1, then 1 multiplies 1. So b is equal to 2, right? And then we can also consider as well the expression 3x minus 1 to be equal to 0. And we come to see that for that expression, 3x will be equal to 1. And then when we divide both sides by the coefficient of the x, we are going to have x to be equal to 1 over 3. Now we substitute 1 over 3 in the equation again. So this time we have 12 multiplying 1 over 3 minus 5 is equal to a. We have 2 multiplying 1 over 3 minus 1. And we have plus b, right? 3 multiplying 1 over 3 minus 1. So we see that this cancels this. We will have 1 minus 1. So the b goes away, right? So 3 will go here 1, 3 will go here 4. So we have 4 minus 5, right? A part becomes a multiplying 2 over 3 minus 1, right? So it means that we will have negative 1 to be equal to 2 over 3 minus 1 becomes negative 1 over 3a. Then when we cross multiply, we have negative 3 is equal to negative a. Then we divide both sides by negative 1, right? So that implies that you are going to have a to be equal to 3. So what conclusion can we draw now? So we can say that therefore, right, we can say that basically when we have a rational function 12x, right, minus 5 all over 3x minus 1, right, and 2x minus 1, we can write it as the a is 3. So we'll substitute the a with the value 3 all over 3x minus 1, right, plus the b is 2. So 2 all over 2x minus 1. So this is resolving the partial fraction, right, or resolving the rational function into a partial fraction. So we are saying that when we simplify the right hand side of the equation, we should get the left hand side of the equation, right? So you can decide to use the alternate method where you expand, get a simultaneous equation and simplify and see if it gives you the same values, right? So now try this third example, right? We are resolving 7x minus 1 all over x squared minus 1 in partial fraction. Remember that x squared minus 1 can be written as, right, a difference of 2 squared, where we have x squared minus 1 squared, and that can be written as x minus 1 and then x plus 1. So basically in this lesson we have gone through the process of resolving rational functions into partial fractions, and what we have seen is that when we have the linear factor, all we must do is that when we segregate them, we must write them in terms of the factors and use a, b, c depending on the number of factors that we have. In our next lesson, we want to look at resolving rational functions by decomposing them, and we'll consider the rational functions that have repeated factors. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.